in this question, this block is given an initial velocity v0. It travels through this frictionless path and reaches a path with friction from C to B, and it stops at B after traveling a distance d. We need to find out this distance d in terms of v0 and h. So for this, you must first analyze that for motion from A to C, we can apply mechanical energy conservation, because work done by any external force, that is normal force, is zero during the path, because normal is perpendicular to the displacement. There are no internal non-conservative forces like friction in this path. Therefore, mechanical energy conservation can be applied from A to C, but mechanical energy conservation cannot be applied from A to B, because there is a friction path from C to B, and friction is an internal non-conservative force doing some work. So we can apply mechanical energy conservation from A to C. Therefore, we get potential energy initial plus kinetic energy initial. Let me call this potential energy at A plus kinetic energy at A is equal to potential energy at B plus kinetic energy at B. Let me take gravitational potential energy equal to 0 at this level for simplicity. Therefore, 0 plus half m v0 square is equal to potential energy at C. I am applying mechanical energy conservation from this point to this point. Therefore, this is C. This is equal to mg h plus, let the final kinetic energy at that point be v1, half m v1 square. Let the velocity be v1 at C. Therefore, by solving this equation, we get v1 is equal to root over v0 square minus 2g h. You intend to remember this value. v1 is equal to root over v0 square minus 2g h. Now we need to find out the distance travelled by the block as it goes from C to B on a friction path. Now, since the object is already having some velocity here, kinetic friction will act on the object, that is equal to mu into n. The normal reaction is equal to m into g. Therefore, the friction force is equal to 0.6 mg, as the friction coefficient is given to be 0.6. The acceleration of the block will be normal mg. The friction force, the initial velocity of the object was v1. The friction force starts acting, that is equal to 0.6 mg. So the acceleration a of the object will be 0.6 g. Now we write the equation for rectilinear motion of the object. Initial velocity is equal to v1, final velocity is equal to 0, acceleration is equal to minus 0.6 g, as we have taken this direction to be positive, and we need to find out the displacement, that is equal to d. So we apply v square is equal to u square plus 2as. That gives us u is equal to v1 square plus 2 to minus 0.6 g into displacement d. Now here v1 square is equal to 1.2 g d. Therefore, d is equal to v1 square upon 1.2 g. Now we know v1 square to be v0 square minus 2gh. We substitute it here to get v0 square minus 2gh upon 1.2 g. So this comes out to be our final answer for the distance travelled by the block when it comes to stop.